Do I see my notes? Yeah, but how do I see my notes? I don't. Okay, that's all
Okay.
right. Just a second.
One more second. Okay, so our last paper. So we'll have Sarvnaz Karimi is presenting the role of context in vaccine stance prediction for Twitter users.
Thank you.
Thank you.
Okay, so I'm presenting on behalf of Aleney. She couldn't be here, unfortunately. This is her honors thesis, so it's based on her honors thesis and at University of Sydney. And yeah, so somehow second author didn't want to present either, so it's up to me. So what's this work on? Why are we looking? We're in this work, we're looking at the stance detection for vaccine hesitancy from social media. Vaccine hesitancy is basically defined as refusal or delay in acceptance of a vaccine, even if it is available. And it is known that the content that is shared on social media, especially negative content that is shared on social media, could have an effect on how people form opinions about certain vaccines. So we're looking at this problem as a stance detection problem, which is basically, stance detection is basically process of identification of a speaker's judgment or standpoint towards a given position. And given in social media, you could publish things that in an account that allows you anonymity, it is very possible that people share content that more freely than in, let's say, in person. So that's the two sides of things that we're looking at in this study. And so what we're specifically looking at is what is the role of users' previous vaccine-related posts in detection of vaccine negative content. And in other words, we want to know whether collecting historical data from users makes sense and is it useful or not. In the literature, you can find a lot of work on, let's say, tweet classification, using context or other tweets as a context for tweet classification. There are a lot of work on using Twitter data for public health, and let's say, for example, for surveillance. There are work on stance detection, vaccination hesitancy detection using sentiment analysis or using topic modeling. But when we were looking at the literature, we realized that there's a gap in that nobody or very under investigated in the past literature, looking at this vaccine hesitancy detection use from a stance detection point of view. So that's where basically we were working on. We looked at the stance detection as a text classification problem. We simplified it as a binary classification. So a stance is usually considered as 3 labels. Usually it's a pro or neutral or against. But for vaccine hesitancy, what is of interest is finding those negative content, because that's where the harm is. That's what you want to to address in different applications. So it would make sense for us to just bundle pro and neutral as one, and against or negative content as one. The data set we had, we studied was from the 4th author, Dunn from Sydney University, had published a paper that they released this data set. They collected a large amount of tweets and related to large group of users, Twitter users, using keywords related to vaccination and immunization. And then they labeled something around 10,000 of these tweets that for vaccine critical content. And so negative, so it's mostly negative, whether negative about vaccines or not. We from this data set, we looked at only those users that had, we at least had 4 historical tweets related to each tweet that we were looking at. So we wanted to have a good amount of history from those users. So anything that was less than 4 historical tweets, we removed those. So the historical tweets are not labeled. They're not manually labeled. So we just have the labels for the original tweets. What sort of classifiers we used? We looked at 2 types of classifier. We can say traditional machine learning type, that is like logistic regression and support vector machines. And then we also looked at Roberta and Twitter Roberta. So Roberta as it is, and Twitter Roberta is mostly we thought, okay, we have Twitter data, so this probably is more domain specific for us. Experimental setup for the traditional methods for logistic regression and SVM, the data was presented as a very simple bag of words. We concatenated historical tweets and the tweets as a one long text. And for transformers, we basically, the tweet that we're interested in is as a sentence 1 and connected to the historical tweets as sentence 2. So that's like the two inputs to the transform to Roberta. We divided the data set into 80%, 20% for training and testing because tweets can have this leak information into the future. If you just randomly split it, we made sure that we time ordered the tweets for our split. And Roberta experiments were repeated 5 times so that we get a standard deviation there. So this is the main results for this work. So the top part is a logistic regression. You can see no HT is historical tweets. So without using historical tweets, and then we're adding one at a time to more and more history from that particular user to the system for classification. You can see that the more content we give, the better the classification gets. That last one is like logistic regression with 4 historical tweets. It's actually statistically significant over the previous ones, better than the previous ones. Linear SVM, even though it looks like it's very much like logistic regression, it's actually not as good statistically. So for the 2 statistical methods, logistic regression did the best. For between all, Roberta with 4 historical tweets was outperforming even Twitter Roberta. And we just for the record to know how much the historical tweets without the actual tweet works, we have the final row to just show you how much it contributes as well. So this is like basically the summary of what we've done. We from those results so the context actually helps. So it helps to collect that sort of data if we are looking at this problem. Historical tweet only was low precision. Obviously, we don't have the actual tweet we want to find the stance for, but it had a high recall. So, and if we use only tweets themselves, we have low recall but high precision. Linear models were really doing well. Like you don't really need to use Roberta for this type of, for at least for us, we didn't see much. Linear models were very simple and very easy to work. So and like simple logistic regression probably is a go-to. And what we saw is that domain-specific pre-training, like Twitter Roberta, didn't actually help in this particular problem, which could be associated to the data because the data was collected for differently. But we still have to investigate that. So that's all I have. Thank you. Any questions? Just mention that Aleney is also online. Maybe she can.
Thanks very much.
Thank you.
Do you have any questions? Or any questions remotely?
Easy.
I'll have a question actually.
Okay,
Sorry.
go ahead.
So did you have, do you have any idea in your data whether you had some users who were expressing, you know, counter stance? So both sides of, you know, a negative and a positive, for example.
I don't know. I haven't, like you want to. Yeah.
Was not necessarily followed by a anti-vaccine. So not all things that anti-vaccine people follow.
Yeah.
But the data was not collected for anti-vaccine, right? It's just, yeah, it could be, it's not exactly misinformation or anything. It's any information that is shared that is not factually correct. Yeah.
Yeah, it'd be interesting to find out. Okay, thanks to our speaker.
Thank you.
So that brings us to the end of ALTA for this year.
If Sarvnaz is still okay to answer one more question, there's one by Stephen here. Sorry, we just saw it here. He says, very interesting. What if you added tweet metadata such as retweet, like follower info to the model? Might accounts be liking and following people with similar stances?
Okay, I think the original data set removed the retweets because we didn't collect the data sets also. Yeah, is it done? Yeah. But we haven't tested with metadata. I don't even think that we have it. But Aleney, you're online, you can.
Yeah. Hi guys. We didn't actually test with metadata because we didn't have it available. The data set only came with the tweet text, etc. So tweet text, tweet ID, the username, and like that point in time. So unless there's some kind of way to link the user ID with that point in time and then check who they're following, I don't think that'll be possible. But I did highlight in my thesis that it would be interesting to try and add those kind of engagement and network stats to see if it would actually improve the like accuracy, precision, recall, etc. Hope that answers your question.
Yeah, thanks. It's super interesting. I think if you have the tweet ID, then you can probably retrieve then the JSON data and then maybe get the followers and stuff like that. But yeah, interesting. Thank you.
No, good. Thank you.
Okay. Thanks again to our speakers.